Welcome and thank you for joining us today. My name is Anthony and I'm here with my partner Tiffany, and today we're going to be talking about the Hayward Fault. Now, you may be wondering what exactly is the Hayward Fault, or why does it even matter, or why are we even talking about this? But through this report and in-depth analysis, we're going to give you all the details of why this is so important, and that this is actually something you should be really worried about if you're living in the Bay Area, and something just really important overall. Okay, so now going into depth of what exactly is a fault, or where is the Hayward fault. So essentially a fault is a breakage in the Earth's crust. It's basically, if you look down at our picture at the bottom of the slide, you can kind of see two separated rocks, like big break. This is essentially what a fault line is. So essentially just a break in the Earth's crust, and these are where earthquake and tectonic activity exactly happens. So we have major plates all around the Earth, and these plates can pull against each other, they can push against each other, they can slide against each other, and this is where the tectonic activity can take place. So if we're looking at a Hayward fault, if you can look at the bottom right hand corner of the photo, it's located in North America, in California exactly, and it starts at the San Pablo Bay, which is Pinole, and it goes all the way down past Berkeley, past Oakland, past Hayward, and all the way you can see down all the way near Warm Springs, which is near Fremont. It's 75 kilometers, and it looks like a straight line, but it's actually kind of a crooked line. It goes through the hills, and it's actually a strike slip fault, meaning that these faults slide against each other, and it's actually a right strike lateral fault, meaning that the right side is more sticking out. And yep. And going more into depth about the Hayward fault, something that we have learned through class and through the readings is that it's a hybrid fault, meaning it has creep and meaning it has some areas that are locked. So to be exact of what this really means is some of the plates are not moving at all, like areas of the fault, they're not moving at all, they're just locked. And then there's some areas of the fault that are moving slowly against each other, as we just learned that was a strike slip fault. And for over 150 years there has been tension building up in this fault, which really has a lot of seismologists and scientists wondering when's the next big one going to come. Based on data and based on various research, we have seen that we could be due for the next big one in the next 30 years or any moment. So it's something to look out for. And how I mentioned how there's slow movement along the fault. This is about 0.2 inches a year, so it is moving very slowly, but over 150 years, you could see where that could be a lot. And like I said, this movement is building tension, and once that tension gets way too overflowed, the fault will rupture, and then the next big one will come. So as you can see with this emoji at the bottom, there is some worry, but we just have to learn more about the Hayward fault and be ready for when the next big one comes. So going a little bit more in depth about the Hayward fault, and something that you need to take in consideration is that it's in the tech hub of the Bay Area. You have Oakland, you have Berkeley, you have San Francisco directly east. Millions of people reside in this zone, and thousands and 10,000s of people are constantly commuting up and down all the way from the North Bay, from the South Bay, from the East Bay, and there's a lot of people activity going around this area, which makes it a really big hazard if something happens, because we have five major highways, 580, 880. We have BART, which is a underground railroad system, and we have Amtrak, which is just the railroad trains going to Sacramento, and we have a lot of tons of water pipelines, and we have the Port of Oakland, which is constantly transporting and importing goods from all over the world. So we're really at a big risk for when the big one comes. And so many businesses, startups and big chain businesses, medium-sized companies are coming to the Bay Area. There's so many buildings, there's tons of people, it's very condensed. So again, this really is a hazard and really is something interesting yet fascinating about the Hayward Fault. And a little something we've learned in class was that we haven't had any activity since 1868, which was an estimated 7.0 magnitude earthquake. So you can only imagine that with all these people around and all these commuters, that when the big one hits, it could be very deadly. And the last bit of information regarding the Hayward Fault is that it's actually kind of sandwiched in between. If you look at the picture on the slide where the star is, that's where the Hayward Fault is. You have the Calaveras Fault to the right, which extends from the south of Hollister to the east of San Jose and Pleasanton. And then you have to the left, you have the San Andreas Fault, which runs from Cape Mendocino all the way to the Gulf of Mexico. As you can see, it's going through the North Bay from Eureka to Santa Rosa, Petaluma, all the way down to the city. You have Palo Alto, San Mateo. So the interesting part again is that when that big one comes, the big question is it, if an earthquake happens in the Hayward Fault, is it going to trigger something on the Calaveras Fault? Is it going to trigger something within the San Andreas Fault? Since so many people live near these faults, there's just a huge risk, and it really is something that scientists and us students have been really wondering, when that big one comes, are we going to be ready, and how traumatic is that damage exactly going to be? So again, if we put this all together, as I have said time and time again, we are due for another earthquake. The tectonic stress has been building up for over 150 years. The big one could be coming now, it could be coming in 2 years, it could be coming in a month, we don't know. And that's the big thing, we can't predict when that's going to come. And if we look at USGS earthquake geologist Emeritus David Schwartz, he says this fault is what we sort of call a tectonic time bomb. And given that we have a 7 million people population around the Hayward Fault, and we have all these major highways, bridges, transportation systems, docks, people, compact residential areas, businesses, we have to question ourselves, are we going to be ready for the next big one? And this is why, again, this is so important to learn about, because if we just put this to the side and don't pay attention at all, then when the big one comes, there's going to be thousands of deaths, there's going to be thousands of catastrophes, and we have to be ready for this. And lastly, for the sake of time, we're actually not going to attach the video, but if you remember from class, we had the actual hypothetical example. And if we can see, you can see this red dot where the epicenter is. This is from the same video. We're just going to go a little bit into depth about it. So you can see the epicenter where the starting point of the earthquake is. We're expected to happen. You can see within, this is only 72 seconds, so roughly a minute, like 12 seconds. The intensity, the red is indicating worst intensity, yellow is a little bit below that, blue is a little bit below that, and so on. So from looking at this, within 72 seconds, this rupture of the fault has already extended all the way down to Richmond, Oakland, Fremont. As you can see, it's already approaching San Jose. It's not quite approached Santa Cruz, but we can see that it's becoming close enough to the yellow zone to where it becomes more affected. And again, like I was talking about, only within a minute, all these big tech hubs are hurt tremendously. San Francisco, San Mateo, Palo Alto, San Jose, Oakland, and it only takes a couple of seconds for the quake to really start making some motion, so we have to be ready again. And it's just something important to know that when the big one hits, that within 7 seconds, the buildings and ground could be shaking tremendously. And next we're going to go more into depth about the potential hazards that could arise from the earthquakes, because not only is the earthquake deadly enough, there are different things within the earthquake that can happen: fires, landslides, liquefaction, and of course infrastructure damage across all platforms. So going more into depth, if we look at the infrastructure damage, as I've mentioned time and time again, buildings, transportation system, major airports, the Port of Oakland, docks, these could be destroyed. As you can see in this photo below, this building has collapsed on a car. Major buildings could be destroyed, such as the Federal Reserve Bank, tall buildings. We have bridges, the Golden Gate Bridge, we have the Richmond Bridge, we have the Bay Bridge. These are collectively having millions and different thousands of people coming each day, commuting, traveling all over the world. So there's a lot at stake in terms of infrastructure damage, and according to some of the readings and some of the articles of what we've studied and read, it could be more than $82 billion of damages alone. So another big worrying point is liquefaction, and essentially liquefaction is essentially, if you can see the photo at the bottom right hand corner, you have a normal stable soil, normal foundation, everything seems to be fine. But when an earthquake happens, essentially because we're so near the Bay Area, there's a lot of water, and the water can go and saturate the soil and the sediment and the foundation, causing this foundation to become really weak and causing buildings. And as you can see, this truck in the left, they could sink to the ground, and essentially the foundation becomes so weak that buildings and trucks and infrastructure are sinking in the ground because of the weak foundation. And as I said, the Bay Area is highly susceptible to this, and this can be problematic, especially major roads, bridges, buildings. And another big part to consider are landslides. These, especially for those who live on the hills, the Berkeley Hills, the Oakland Hills. When there's buildings on hills, these land masses can and rocks can be moved very suddenly. They could be done within an hour. But when these rocks move on the hills, they can collapse and they can be the result of many deaths, injuries, and catastrophe. So that's a big thing that we need to also consider as another potential effect from earthquakes. And another thing are fires. Fires, if we look back from what we learned in lecture and the readings, the 1906 San Francisco earthquake, 90% of it primarily was from the fire. Pipelines broke, electrical pipelines broke, and created fire all around the city. And water pipelines broke, and as a result, firefighters weren't able to get enough water or resources to put out the fire, which was very problematic. As you can imagine, if there's a fire in this situation of the 1906 earthquake, if there's fires all around the city and they need to put it out and they can't get the water, that's very problematic. And you can only imagine if people are trying to escape a condensed area like San Francisco or Berkeley or Oakland and there's fires everywhere, there's could be a lot of crashes, a lot of problematic situations, and it could be a huge hazard for those living around the area. And depending on weather conditions, especially the Bay Area, which is known for being windy, these fires could spread tremendously. And this is a big threat for firefighters as they'll be the ones trying to put this out. And lastly, something that I actually didn't include in the PowerPoint was aftershocks. Aftershocks can be very deadly. They can happen over time. They can happen right after an earthquake. So as an example, if we had a 7.0 magnitude earthquake, we could have consistent or every once in a while aftershocks constantly hitting the earth, or essentially mini earthquakes that could cause even more damage, and we don't even know when they're coming. And if there's fires, if there's multiple damages across all infrastructure, and there's landslides, and if there's liquefaction, you can only imagine the different deaths and hazards this could have to citizens. So it's important to understand that there are different after effects that can happen as a result from an earthquake on the Hayward Fault. And again, as I say, we have to be ready and understand that this is really no joke.
Hi, I'm Tiffany, and I'll be talking about where the Hayward Fault affects us on campus. Our campus essentially lays on the Hayward Fault. For example, the Hearst Memorial Mining Building is only 800 feet away from the Hayward Fault. The building was built in 1907, and between 1998 and 2003, the building went through seismic retrofitting. The renovation included moat cover panel, moat wall, base insulator, steel piers, foundation, concrete beam, and first floor. As part of the renovation, the Hearst Memorial Mining Building was lifted from the ground from its original foundation and separated by seismic base oscillation, which are rubber and steel circular columns which absorb shock. This was a new foundation for the building. To be specific, moats were installed at the foundation of the Hearst Memorial Mining Building, and moats are seismic base isolators. They absorb horizontal ground movement up to 28 feet in any direction. This prevents the building from moving when there is an earthquake. This means that all parts of the building must be attached to the new foundation of the building and not to the ground itself. Because if a wall on the side of the building is attached to the ground and not the foundation, then the wall will not be safe during the movement of an earthquake. If you thought 800 feet was too close to the fault, think about this. California Memorial Stadium sits directly on the Hayward Fault. To protect the the stadium against any earthquakes, there are expansion joints placed on the outer walls of the stadium where it crosses the fault. You can see visible cracks in the stadium of where the fault has shifted, and the fault creeps a couple millimeters per year, so you can see visible cracks in the bleachers, on the stairwells, and on concrete paths. Here is one example of the north side stairway. The fault has affected the stairway because you can see that there is a crack in the middle of where the pole crosses the concrete. Inside the bleachers on section KK, we see a large shift due to the Hayward fault inside the stadium. This is an infamous example because it's very famous within researchers and within news articles. This is section KK of Memorial Stadium, and the fault movement has caused a gap of about 6 to 7 inches. Here we see inside the stadium. This is the concourse level. If you look closely, under the concrete structure, there are curved cables and pipe-looking things. Those are flexible conduits. These are cables and pipes that are flexible because in case of an earthquake, we don't want cables or pipes to rupture. Therefore, the flexibility prevents any rupturing. Inevitably, faults will cause offset curves. On the left is a picture of Dwight Way and an offset curve. On the right is another picture of an offset curve. However, this is not in Berkeley, but is still affected by the Hayward fault. The Hayward fault is naturally right lateral. Therefore, if you're looking at the fault, then anything on one side of the fault will move to the right due to the creep. That's why you can see the curves are shifted one way versus another. If you have ever passed Strawberry Creek on campus, it is interesting to know that the Strawberry Creek is also affected by the Hayward Fault. Strawberry Creek has a natural westward downhill flow. However, due to the fault, it has shifted 600 feet from its original placement. The fault blocked the creek due to a shutter ridge caused by the right lateral movement of the Hayward Fault, and the fault has offset the creek from about 1,100 feet northwest. After those 1,100 feet, the creek continues its westward downhill flow. Overall, I hope everyone enjoyed our report on the Hayward Fault. Being a part of the Bay Area community, I hope that everyone takes a lesson from this and knows how to be prepared for the severity of the earthquake that could happen due to our closeness to the Hayward Fault. Thank you for listening.